In today's session, we are going to discuss about projectile motion. So what's a projectile? By definition, a body thrown upwards in any direction from the Earth's surface or a point close to it is called a projectile. So what's a projectile motion is? A projectile motion is basically a two-dimensional motion. Unlike kinematics, in kinematics we have seen what we have seen. We have seen that the particle or any object was moving in a straight line. That was a rectilinear motion or a motion in one dimension. But in projectile motion, what we are going to consider is it's a two-dimensional motion or motion in a plane. So like for instance, if you consider means when you are throwing a basketball to its basket, so that basketball is transcribes a path which is a parabolic in nature, and it's a two-dimensional motion or in a plane. That is, the basketball is moving the to along the horizontal as well as in the vertical direction. So let's just continue our discussion on that. So for that, let's just begin with a diagram, and for this we are not going to analyze any special cases of it. So we are going to have a general approach, and then we will derive the special cases from it. So as you can see in the diagram, if we consider this one as our horizontal, so we are considering here an inclined plane which is making an angle alpha with the horizontal. So if we consider this horizontal axis to be our x axis, then this is our shifted x axis, or we name it as x dashed, and hence accordingly this one which is perpendicular to x dashed axis, we name it as y dashed or shifted y axis. So from now on we will be going to refer x dashed as our horizontal and y dashed as our vertical. So these are basically the shifted horizontal or shifted vertical things. For generalized approach, we are considering this inclined plane, projectile motion in this inclined plane. So now if you can see here, this particle is thrown vertically upwards with an initial velocity u. So, and if we consider this angle to be theta, then we can resolve this initial velocity vector in two components. One is the horizontal component ux0, 0 stands for initial, and uy dashed 0. So this is the vertical component of the initial velocity vector. Now let's define some of the terms here, like this is the maximum point with respect to this horizontal. So if we consider this height is our maximum height h, we name it as h. And if we consider this x dash as our horizontal, then we are naming this distance between the end point and the starting point, we are naming this distance, horizontal distance, we are naming it as r, that is horizontal range. So this is what this r is, this is horizontal range. And what is this h? This is maximum height. Okay, so if we consider that from starting to the end the time taken is capital T, so that capital T will be total time of flight. And if we consider to reach this maximum point, the particle or the object takes a time ta. So ta will be time of ascent, and if the particle takes a time tb to start from this maximum point and end in here, that is our tb or time of descent. So as we can see, the t total time of flight is nothing but ta plus tb. Okay, so moving on to the analysis. So let's just brief it once again. So we are considering an object here which is situated in an inclined plane. The inclined plane is at an angle alpha with the actual horizontal. So we are considering this along this inclined plane, we are considering as x dashed or shifted horizontal axis here, and we are considering a perpendicular axis to x dashed which is y dashed. So we'll be referring this y dashed as vertical from now on, and we'll be referring this x dashed as horizontal from now on. And we are considering this initial velocity of the object is u, which we have resolved it into two components. What is ux dashed naught is the horizontal component of the velocity, initial velocity, and uy naught is the vertical component of the velocity, initial velocity. So we can write it here, u x dashed naught will be our u cos theta, and u y dashed naught will be u sin theta. And this maximum height from this x dashed axis is capital H, so we are considering it as maximum height, and the distance between the initial and final point is the horizontal range here. And the total time taken is the time of flight, which is nothing but the summation of time of ascent and time of descent. Time of ascent means the to reach the maximum height, and time of descent means after that the rest of the time. So, and one more thing we can consider, we all know that g is downwards, g is always downwards here. So if this angle is theta, we can consider, we can resolve g also in two different directions. One is, this one is the vertical component or g y dashed, and this one is the g, sorry, let's just remove it from here. So this is our g x dashed. So what is our g x dashed and g y dashed? G x dashed will be, if this angle is alpha, then we can see here, if this we have considered, so if this is the our horizontal plane, then if this angle is alpha, this angle is also alpha, so this will be our alpha here, and you can derive it by simple geometry that this angle is alpha. So g y dashed will be g y dashed will be g cos alpha. So vertical component of the g acceleration due to gravity will be g cos alpha, and uh, horizontal component of g will be g sin alpha. Okay, so let's move on to our analysis now. So let's just continue our analysis here. So in this maximum point, the vertical velocity, vertical component of velocity or uy will be 0 at maximum point. So at maximum point, if we consider, if we apply the equation of kinematics, v square is v is equals to u plus or minus at. So here will be getting 0 at maximum point. The v means final velocity, uy will be 0, So it will be equal to, the initial component is u y0 y dashed 0, or it is u sine theta minus, why it is minus, because we can see in this g y dashed or vertical component of the acceleration due to gravity is directed downwards, whereas the initial velocity u y dashed 0 is upwards. So what will happen is, this upward velocity will decrease, it will decrease to 0 at maximum point, then it will start increasing until it reaches the end point. Okay, so it will be u sine theta minus, not plus, minus gy dashed means g sine alpha, so it will be, sorry, gy dashed is g cos alpha, so it will be g cos alpha into, what is the time, so this is the time of ascent, because time of ascent is the time to reach the maximum height, so ta. So from here we can get ta is equals to u sine theta divided by g cos alpha. So let's just box it, because we'll be going to need this. So this is our equation 1 we are getting. So now what is the total time of flight we can write, or before that let's just mm, let's just calculate the maximum height. So what will be our maximum height? So maximum height will be, if we if we apply the equation of kinematics, h is equals to ut plus or minus half gt square. Here we will get the displacement at maximum point, the displacement, vertical displacement is h, that is our maximum height. That will be equal to the initial velocity u y dashed 0, or that is u sine theta ut, time of ascent, minus because g cos alpha is directed downwards and u sine theta is upwards, so minus half g cos alpha ta square. Okay, so if we put the value of ta here, what we will get? We will get here u sine theta, and u sine theta will give you u square sine square theta by g cos alpha, and here you will get g cos alpha t alpha square, so you will get u square sine square theta, and g cos alpha will cancel out because g cos alpha is not equals to 0, so you will get again u square sine square theta divided by 2g cos alpha. So from where here, what will you will get? You will get h is equals to u square sine square theta divided by 2g cos alpha. So here we get our second equation. Okay, here we get our second equation. So now if we consider the entire time of flight, so what will be our entire time of flight? The entire time of flight is t. So after, if you can see here, the particle started from here and started from here. So if we consider the total time of flight, the displacement, the vertical displacement, means the displacement along y dashed axis is 0. If we consider the initial and the final point, you will see the net displacement along the y dashed axis or along the vertical is 0. So if we write it here again, this h is equals to ut minus half gt square formula, from if we apply it here, you will get 0, net displacement, net vertical displacement is 0. That will be your equal to u sine theta, initial velocity is u sine theta into capital T, the total time of flight, minus half g cos alpha into capital T square. Okay. So what we get here is we are getting, so we can cancel one t and t here because total time of flight is not equals to 0. So we are getting t is equals to 2u sin theta by g cos alpha. This is nothing but twice of time of ascent. So this is equals to 2 time of ascent. So what will be our time of descent? Time of descent will be, so time of descent will be t minus time of ascent. So it will again give you u sin theta by g cos alpha, which is nothing but equal to time of ascent. Okay, so here name it as equation 3.